Good morning. My name is Joshua Hailpern. I'm a PhD candidate at the University of Illinois at Urbana-Champaign in the United States. And we've been doing some really exciting work that I'm looking forward to sharing with you today. So I'm just going to dive right in and say, if you were to ask somebody in the general public what they think the future of computers are going to be like, on almost everyone's list is going to be voice-controlled computers, speech recognition. But if you think about it, people aren't really talking about speech recognition. They're not talking about the ability of a computer to identify a word that you're saying. What people are really getting at is the ability of the computer to respond intelligently to the context that a user is working in. The ability of the computer to understand what's important to its user at a given point in time and respond accordingly. One of my favorite movies of all time is 2001: A Space Odyssey. And in this film, there's a very large spaceship, and controlling that spaceship is Hal. Hal is a computer. And Hal has the ability to respond to voice commands. It can perform very complex data analysis. It can look up information. It can even read human lips. And at one point in the film, Hal, the scientists on the spaceship, they are planning on abandoning their mission. And Hal is able to discern the intent of the scientists, the implication of them abandoning the mission, and Hal decides that the best way to go forward is to kill them. Now that's really cool. I mean, not the ability of Hal to kill someone, but the ability of Hal, the computer, to understand what's important to its scientists, to understand the implications of their actions and, based off of its heuristic, respond accordingly. But back in reality, and back in what computers can do today, that's a really hard problem. But this notion of the computer to be able to understand this qualitative notion of importance is pervasive in many forms of human-computer interaction. Consider interruption research, or the ability of the computer to determine when to annoy us with one of these pop-up windows. Some information that we get is more important than others. I mean, consider a PhD student in his 5th year getting an email from his advisor saying, "Don't worry about writing that dissertation. You're just so great, we're going to let you graduate." No matter when that email comes in, it's important to the user. But also consider an email that says, "Hey, I found a great reference that might be good for your paper that you're working on." Well, that information is more important at some times when you're actually working on the paper, and less important if, let's say, that you're watching a movie. But the computer, to determine when to interrupt you, has to know what's important to you at that point in time, what applications you're using. Another example is contextual computing, right? The ability of a computer to give you pertinent information depending on what your current activity is. We all remember Clippy, the avatar in Microsoft Office that would pop up and say, "Looks like you're trying to write a ransom note. If you threaten bodily harm, you can increase the money you can get by 50%, right? I mean, it didn't work out that great. But we all would love to have this kind of virtual assistant across multiple applications, or maybe even our daily lives. But for that to be an effective tool, it needs to understand what's important to a user at a given point in time. And one last example, if you'll humor me, is task analysis or time management work software. And in this area, the user wants to understand where they've been spending their time during the day. And even in some situations, to resume existing tasks that they were doing maybe yesterday or the day before that. Now, it's commonly done in task analysis work in one of two ways. The first is the computer says, "Well, I see that you have Word open, and Word means that you're doing work. And now that I see that you have Photoshop open, and Photoshop is play." But that one-to-one mapping of a task to an application really doesn't make sense. I mean, a graphic designer doesn't use a Photoshop for play, they use that for work. And what do you do with a web browser, which spawns multiple types of activities? The other way it's commonly done in task analysis is they say, "Well, user, why don't you tell me which applications you're using right now? And then give me a tag or a couple of words to describe them." And then later in the day, when the user searches for that, the computer says, "Aha, I know what you're doing." Well, no, it doesn't. I mean, that's not an intelligent computer system. You told the computer what you're doing. It's just regurgitating the information you provided. But in the situation when contextual computing, task analysis, and interruption research actually is being done intelligently, they're all predicated on the notion that if you know what window and what application is in focus, You know what's important to a user. But that is a fundamentally flawed assumption. Think about it. Window focus is binary. Only one window of one application can be in focus at any point in time. But with the current state of computers, being able to run multiple applications and the size of modern screens, multiple applications can be used simultaneously to perform an activity. Even modern computers allow you to scroll in windows that aren't even in focus. Let me give you a concrete example. Here's a screenshot of a graphic designer's desktop. She's working on a presentation for the Park Service. And if you were to ask her which applications are important to your current activity, she could unequivocally say PowerPoint and these two Safari windows. And for the PC users, Safari is a web browser. But if you look at the applications that she has running, she has Photoshop, she has Illustrator, she has document editing software up, she has Mail, she has Calendar, she has iTunes, and multiple of these applications actually have windows that are taking up the desktop. But if you were using window focus alone, it would only capture that one PowerPoint window. And that's what I'm going to be talking about today. A new approach to allow computers to identify what's important to a user at a given point in time. This qualitative notion of importance, but we're going to base it on quantitative information. And to do that, we did the Clotho project. Our goal was to map quantitative aspects of computer usage, such as CPU consumption, window size, mouse position, window focus, and map that with the qualitative notion of importance. And to do that, we recruited users for a 5-day-long study in which we instrumented their computer with a suite of applications, specifically Clotho Logger, Clotho Debriefer, and Clotho Cleaner. Now, during this 5-day-long study, users would be running Clotho Logger. And periodically through the day, this window would pop up. We did experience sampling. And we would ask users to write down what their current activity is. Now, this information was not returned to scientists. So for people who were working at a company or doing information that they didn't want to share with us, we wouldn't ever find out, and they could be completely honest. Meanwhile, Clotho Logger was also keeping track of everything that we possibly could on the user's computer, such as CPU consumption per application, RAM, window size, window area, mouse position, yada, yada, yada. We had the one stipulation that anything that we record and monitor could not slow down the system's performance, so we weren't able to get things like read or writes per disk per application. At the end of each of the 5 days, users would run a debriefing program. This debriefer told them